Welcome to the partial fractions saga part 1. So, fractions. What are they? Well, we know how to manipulate expressions like the one I've just drawn a yellow bubble around, put them into a single fraction form. So what we would do is we give ourselves a common denominator of x plus 2, x plus 1. And then the top fraction would get multiplied by x plus 1, and the second fraction would get multiplied by x plus 2 to accommodate for the fact that you're creating a common denominator. And then we'd simplify that out. So let's make that x squared plus x plus 3x plus 6 all over x plus 2, x plus 1, which gives us x squared plus 4x plus 6 all over x plus 2, x plus 1. Okay, but what happens if I'm given the answer and I want to go backwards? So this is what partial fractions this allows us to do, is to work these processes in reverse. In order to be able to do partial fractions, you'll need two things. First off, your fraction, the one that you're trying to split back up into its sort of addition or subtraction, whatever it ends up being, has to be a proper fraction, which means that the degree of the numerator has to be smaller than the degree of the denominator. What that means is that if I have a linear expression on the top, I have to have a quadratic or a cubic or something on the bottom. So, as long as the degree, which is the highest power of x there, is smaller on the numerator, you can do partial fractions. Once you have established that you have a proper fraction, the next thing you need to establish is what type of denominator you have, because that will determine what you do. So either your denominator has to be linear factors, so x plus 1, x plus 2 for instance. And even if you have to factorise a quadratic to get to them, you should do that because that will tell you. Second is something like x plus 3 squared, so you've got a linear factor but it's repeated, so it's written with a square or something like that in it. Or you have an irreducible quadratic, so it's a quadratic that cannot be split into factor pairs that have whole or real numbers. So it's a quadratic that cannot be factorised. So the first one we're going to talk about in this video, and then go to the next videos for the other ones, are where you have linear factors. So we have two linear factors here. Ta-da! And we are trying to work out what two fractions we would have added together to give us that answer. So we know for a start that we are going to have a denominator of x plus 1 and a denominator of 3x plus 2, because those are the two factors we have in our denominator from our new fraction. We don't know what a and b are yet. We don't know what the numerators of those fractions is, and that's going to be our task. It's going to be working those out. How do we do that? Well, we do know how to go in the opposite direction. We know that if we started with a over x plus 1 plus b over 3x plus 2, we could go towards ending up within a single fraction, because we've been doing that for years. So let's start doing that. First thing I need to do is create a common denominator for both parts of the fraction. So let's start doing that. Now, that's my common denominator. What did I have to do to the first fraction to get that? I needed to multiply the denominator by 3x plus 2, so I need to do the same to the numerator. And then multiply the second fraction by bx plus 1, which would give me overall the fraction x plus 1, 3x plus 2 on the denominator, and then a lots of 3x plus 2 plus b lots of x plus 1 on the top. And that is equal to our original fraction, because that's what we're trying to aim. We're trying to get this process in reverse. Okay, now the denominators are the same, so I can ignore those for the time being. And I now have a little equation, which I'm just writing out now, that I can solve to try and find a and b, because ultimately that's what we're interested in. We're not interested in x, we're just interested in a and b for the time being. Okay, so our little expression was this. Now, how am I going to find out what a and b are? Well, the method that works for everything, so it's the easiest one to remember, rather than remembering multiple methods, is to compare coefficients. What that means is we're going to work out all of the different expressions with an x in them, all of the different expressions with just a number, and then look at what each one of them holds the value for, either side of the equal sign. So, at the moment, I can't tell you how many x's are wrapped up in my 3x, because I've got an a outside the bracket. So let's multiply everything out to find all of our expressions. So we're going to end up with 3ax plus 2a, just multiplying brackets out, plus bx plus 1. Now, x expressions, I've got 3a lots of x and b lots of x's. And then in terms of numbers, I've got 2a and, oh, that's a b, multiplying that out, and b. Okay, so compare coefficients. For x, 2 lots of x should be equal to 3a lots of x's plus b lots of x's. Because if I've got 2 lots of x, then 3a plus b must also equal 2. And likewise, I've got -1 numbers, so I've got the number -1, and that has to be made up of 2 lots of a plus b. Now we've got simultaneous equations we can solve, so let's do that. B is -1 minus 2a, just move the 2a over to the side, substitute that in there. So 2 is equal to 3a minus 1 minus 2a, which is b, so that bit's become that. So 2 is equal to a minus 1, which implies that a is 3. Okay, a is 3. So what's b? Well, b is -1 minus 2 lots of a. B is -7. Okay, good. So we found the things we wanted, which were a and b. So in our expression that said a over x plus 1 plus b over 3x plus 2, we know that a is 3 and b is 7, so I'm going to turn the plus into a minus. And that original fraction that we had, which is in your booklet, that does not look like a 3, does it? Wait, even is that? Oh, it's not coming out. Oh well. 3x plus 2. So those two fractions, when you subtract them from each other like that, will give us our original expression. And that is, I guess, algebraic fraction addition in reverse, or otherwise partial fractions. So in the next video, we're going to talk about the linear repeated roots, and then the third video we'll talk about quadratics, and then you will have mastered partial fractions.